me start recording. So for this one, right, again, you can't use the quadratic formula. I mean, if you really wanted to use it to check, that's fine. But I say, though, solve this by factoring. Okay, but notice, though, I mean, you have to be a little bit careful at first, right? Because you want the right-hand side equal to 0. But it's not equal to 0. It's equal to 16. So what do? We subtract 16 from each side. And we get this, as you can see. Now, what do we want? Well, again, here we have a polynomial with 3 terms, right? Right? 3x squared, it's degree 2. There's 3 terms. The leading coefficient's not 1. So you have to use the AC method, meaning you want 2 numbers whose product is negative 16 times 3, and the sum is negative 8. I mean, there might be a little trial and error here, but again, the numbers that end up working are negative 12 and 4, right? Because negative 12 times 4 is negative 48, and the sum is negative 8. So what we want to do is replace this negative 8 with negative 12 plus 4. That's what I'm trying to show down here. I hope this makes sense. I'm replacing negative 8 with negative 12 plus 4. So in particular, negative 8x, I'm going to write that as this. Let me see if they can see that. So, oh yeah, they can see it. Okay. Just want to make sure you can see it. Okay. So that's what happens here. And that's what I'm doing over here, actually. I'm replacing negative 8x with negative 12x plus 4x. Notice also, I mean, you really don't have to do this, but I wrote the addition in front of the third term. So in other words, I could have theoretically have written 4x minus 12x. That's still negative 8x. But I like to keep addition in front of the third term if I can. Because then when I form groups like this, I don't have to worry about distributing a negative. So basically we have this here. And what do we do next? We want to factor out the GCF from each group. I know I didn't check at the beginning there was a GCF. I probably should have. But hopefully you can see here that the GCF would be 1. So mostly because 3, the only common factor of, because there's a non-zero constant term here, you can't factor out x. And also, the only factors of 3 are 1 and 3 itself, and 3 is not a factor of 8 or 16. So the GCF for this thing would be 1. If you did not find the GCF in the beginning here, that's okay. I know theoretically you're supposed to, but you can see I forgot to. So, okay. I mean, on a test or a quiz, when you're doing this kind of factoring, I'll be explicit. So anyway, so we have this now, right? I mean, I'll be explicit to tell you what I want you to find. Okay, so here we want to figure out what this is, right? We want to factor this. We have the 2 groups, right? And basically what we're doing is, let me go back again. We have factor by grouping, right? We took this in the AC method. You're converting it to 4 terms. So we can use factor by grouping. For the first group, let's find the GCF and factor it out. The smallest exponent of x is 1. As you can see, 3 is a factor of 12. In other words, the greatest common factor of 3 and 12 is 3 itself. So that tells us the b in that GCF is 3. So the GCF, 3x to the m, what you can factor out is 3 times x. And now I factored it out, and I got this. Okay. Again, I'm showing more steps than you have to show. So I err on the side of caution. 4x minus 16, as you can see, it's the same idea. Namely, the GCF of this, there's a non-zero constant term. So we can't factor out x, so I'm taking m to be 0. 4 is a factor of 16. In other words, the greatest common factor of 4 and 16 is 4 itself. So we factor 4 out. Doing so, our GCF is 4 times x to the 0, but that's just 4. So 4x minus 16 is this. We factor out 4, as you can see. Okay? And notice we're in good shape, right? Because x minus 4, that's a factor here. This is a factor here, right? X minus 4. So in other words, in parentheses, we have a common factor, x minus 4. That's what we want. Okay, so let's keep going. So together, we get this is equal to this. And so what do? Well, we see a common factor of x minus 4. Let's pull it out. So we pull it out by taking out the common factor, right? To get what's left over, we divide. And so we get this. And really the hard part is done. Because now we set this product equal to 0. And basically that means we set each factor equal to 0 and solve. From the first one, we get 4, right? You just add 4 to each side. Here, same idea. You subtract 4, but then you divide by 3, and you get x is negative 4 thirds. That is what we get here. So our two answers are 4 and negative 4 thirds. And also you can see I forgot to check, even though technically you should check. If you forget to, if you don't check, like on a quiz or something, that's fine, or exam. So you can always check on your own, I guess, in your scrap paper or whatever by you could do that. So right, so so that's what happens here. Was that too fast for anyone? You know what, wait, let me do this instead. Let me stop the recording.